So now we'll see the elimination of elimination, that is in terms of factorization. So here we have a matrix A, so that can be factorized as the lower triangular matrix and upper triangular matrix. So that is represented, that can be written as A is equal to L into A. It means if I combine this, the lower matrix, if I multiply this lower matrix with the upper triangular matrix, I'll get back my A. So to see this, let us take an example here to understand this. So forward from A to U. So I'll take one example here. So is that so we'll take this as E21 into A, because I'll write this elimination matrix later. So before that, let me write the A matrix here. So A matrix given is a 2, 1, 6, 8. So we know that if I want to bring it in upper triangular form, so then I have to remove this 6 from this matrix. To remove this 6 from the matrix, so what I need to do is that either I can multiply this row by 3 and subtract from row 2, or I can multiply this with the elimination matrix. So elimination matrix is nothing but the modified identity matrix. So here I have to write that term which I want to, here I have to write that multiplier term which I want to subtract with. So this remains to be your identity matrix, so that I have changed, so that has become E21 matrix, that is elimination matrix. So E21 represents that in the position 2, 1 means the second row in the first column. So there we have written that multiplier value. So that is why the name is given as E21. So now let us multiply these and see what do we get here. So the first row remains to be same, no change, and here we'll get this as 0, and here we'll get this as 5. And this is perfectly in the upper triangular form, so we'll write this as U. So now let us perform the reverse order of this and see what do we get. So reverse order is nothing but let us multiply this back again, the inverse of this elimination matrix, so with this U matrix. So this is the upper triangular matrix. So how to get this inverse of this? So inverse is nothing but here we are subtracting the multiplied factor of row 1 from row 2. So now instead of that we will add it. So here when we add it, the multiplier will become positive. So then if I find this in this way, that is E21 inverse into U, so then my inverse of the elimination matrix is nothing but it is 1, 0, 3 and 1. So this is my inverse of this elimination matrix, and let me write our U matrix here, that is 2, 1, 0, 5. So now let us multiply this. So what do we get here? So I'll get back my first row as it is, and the second row is 3 plus 3 into 2, 6. I'll get back my 6 here, so here I'll get 3 plus 5, I'll get this as 8. So this is perfectly, we got back our A matrix. So this is nothing but A matrix. So this inverse, what you have written, so if you can see this matrix here, so this is perfectly in a lower triangular form. So this I can also write this as L into U. So it means the inverse of the elimination matrix is nothing but L into U. Therefore, so I can get my A from L into U. It means if I multiply this lower matrix with the upper triangular matrix. So the definition goes like this. So let me write the definition here. So A is equal to L into U. This is elimination without row exchanges. The upper triangular U has the pivot on its diagonal. The lower triangular L has ones on its diagonal. The multiplier Lij, the multipliers Lij are below the diagonal of L. So that is what, if you can see here, that the lower triangular matrix, that the multiplier, that is multiplier here is 3, it is below the diagonal. So that is what it is telling in case of a lower case. So now let us take an example of a 3 cross 3 matrix here and see this. So let me save this page here. Okay. So now A matrix is given. So I'll just quickly write, I'll leave it to you as a homework example. So you find out its by applying the Gauss-Jordan process. So find out its upper triangular form and lower triangular form. So A is equal to 2, 1, 0, 1, 2, 1, 0, 1, 2. So now to bring this in upper triangular form using Gauss-Jordan process, or we just by elimination process, what we can do is that we can write here. So now I have to remove this step. So we'll go with the elimination matrix. So I have to remove this. To remove this, what I need to do is that E21 into A. So I'll multiply. So this is equal to, so now what is E2A? So I have to multiply this. So I'll write this as -2, and the other things will remain to be as it is, unchanged to this identity matrix. So then you multiply with this. So I'll get 2, 1, 0 here. So here 1, 2, and 1. So here 0, 1, and 2. So now when you multiply this, so what do you get here? So first row will be as it is, 1, 0, 2, 1, 0, 0, and here you will get this as 0. Sorry, it's wrong. So sorry, it's not -2 because its second row is 1. So basically it's supposed to be an half. It's a -1/2. So it's a -1/2. So then if I do this with -1/2, I will get this as 3/2 and 1, and the last row remains to be as it is, 0, 1, 2. So this is fine. So next step is that I have to eliminate this term here. So to eliminate this term, I have to multiply this by 2/3. So next is that, so E2, so what is that, E22 into A is equal to, so now I have this term, not E22, sorry, mistake. So this is E32. E32. So this is identity matrix 0, 1, 0, 0, then 0, 1, 0. So we'll modify this identity matrix with 2/3 here, that is -2/3 here, and here it is 1, and then you multiply this with 2, 1, 0, and 0, 3/2, and 1, and 0, 1, 2. So finally when you do this multiplication, so finally what we get is that we'll get our upper triangular matrix 0, 1, 0, and this is 0. So here this is remains to be 3/2 and 1, and here I'll get this as 0, 0, and here the last term is 4/3. So now if I want to write this as in terms of inverse, so if I combine these inverse matrix, if I combine this inverse of E21 inverse with E32 inverse I'll get my L matrix. So if you want, we can just try out. And this whatever we got, this is my U matrix now. This is in upper triangular form matrix. So let us try this, whether we get this or not. So what is my E21 matrix? So E21 matrix is that. So this is 1 0 0. This is minus half 1 0. And this is 0 0 1. And this, sorry, this is I'll get this as plus because here I'm going to represent this positive values. 1 0 0. This is 0 1 0. So then here I'll get 0. So I'll get here 2 by 3, 2 by 3 and 1. So if you multiply this, then definitely you will get this L matrix here. So then this is nothing but, so this is 1 0 0, this is half 1 0, and this is 0, 2 by 3 and 1. Fine. So now if you see this and you see the upper triangular matrix, so now this is nothing but my L matrix. So now it has been factorized. So it means I can straight away write this as, so this whatever we have written here, that is split. Now this is, we can write this as L into U form as 1 0 0 half 1 0 0 2 by 3 1 into the upper triangular matrix, that is 2 1 0 0 3 by 2 1 and then 0 0 4 by 3. So this is nothing but, this is L into U, which is equal to A. So let me bring this little down so that you can see this term. So this is nothing but, I can write this here exactly. Now this is whatever the identity matrix with all my multipliers in place with positive sign. So this is nothing but my lower matrix, and so if I multiply this lower matrix with the upper triangular matrix, I'll get back my A. So this is one of the example of this factorization. So in fact this can also be written in one more form. Let me save this page here. So this can also be written in this form as A is equal to L into U. This we already seen. We can write this as a factorization of lower triangular matrix multiplied with the upper triangular matrix. Or this can be further splitted into L D into U. So D is nothing but a diagonal matrix. Now in the previous example that we have seen in a 2 cross 2 matrix, that the L matrix is nothing but 1 0 3 and 1. So and upper triangular matrix is nothing but 2 8 0 5. Now if you see the lower triangular matrix, its diagonals are 1, whereas the upper triangular matrix, its diagonals are not 1. So what we do is that we will introduce here one more matrix, that is a diagonal matrix, which divide by itself, and that will give our upper triangular matrix. So the lower triangular matrix remains to be same because its diagonals are 1. So now the pivots we will write in a separate matrix because pivots exist in the diagonals. So these pivots here in this case is nothing but, that is 2 and 5. So 2 and 5 I will write here in this diagonal matrix, and this upper triangular matrix will divide by itself, by its pivot. So this becomes 1 4 0 1 4 0. This is 5, 5 divided by itself, so it is 1. So now this is L D into U. So A can also be factorized into lower triangular matrix, diagonal matrix, and upper triangular matrix. So this is another way of representation. I'll look into the transpose and permutations. Let us look into the transpose and permutations. We'll see basic rules here. We will not go in much detail because we know what is a transpose. So it basically changes the rows to column and columns to rows. So just as an example, I'll give one example here. So for example, we have a matrix A and it is 1, 2, 3 and its values are 0, 0, 4. So it's A transpose can be written as, now the rows turns into columns. So now this is 1, 2 over the diagonal. Okay, so you have to remember that it is over the diagonal. So now it will become 0, 1, 3. So now we'll look into a few of its properties of the transpose. In case of sum, then the transpose of A plus B is the transpose of A plus B is equal to its A transpose plus B transpose. Then the product is the transpose of A into B is equal to A transpose into B transpose. Now we'll talk about the inverse of a matrix. Now the transpose of an inverse is nothing but it is A transpose of inverse. So A inverse of transpose is equal to A transpose of inverse. So these are the few properties that we should know. So symmetry. Okay. Now we'll see the one more term here, that is the P into A equals to L into U factorization. Now we will take the permutation also into a picture here. So for example, let me clear this. Right. PA equals L into U factorization. So it means that if A in the first row, if it has a pivot with a 0 value, then we use a first permutation matrix, then we'll interchange the rows. After that, we will factorize this into L into U. So now let us take an example to understand this. For example, we have a matrix, say this is 0, 1, 1, this is 1, 2, 1, then 2, 7, 9. So this is our A matrix here. So we cannot we cannot factorize this, or we cannot find its upper triangular form because the first pivot itself is 0. So to do this, what we need to do is we'll multiply this by permutation matrix. So what I do is that I'll bring this first row to the second row and second row to the first row. To do that, we have to write the identity matrix in the order such that I want to interchange this. So I'll interchange the rows of a 3 cross 3 identity matrix here. So first row and second row are interchanged. So this is my P. So P into A is equal to, now you write here our A matrix here, that is 0, 1, 1, and this is 1, 2, 1, and this is 2, 7, 9. So what happened is just the rows get interchanged with this. So 1, 2, 1 will come here, and 0, 1, 1 will come here, and then 2, 7, 9. So now quickly factorize this. So now I have to remove this this first coefficient in the row 3, that is 2. So it means I need to multiply this first row by 2 and subtract by third. So here my the lower triangular matrix, here in this place it will be 2. So then what I will do is that after that I have to remove this value. I have to remove this 7. So before that I need to get that in a proper form. So let us do that. So before finding, let us do in the same traditional way. So E3 1 into our P into A matrix, which is equal to, so now it is 1 2 1 0. Sorry. Here I have to write my triangular matrix 0 1 0 identity matrix. So here I have to write this as -2, and then this is 0 and 1. So I have to multiply this with sorry, this is 0, this is 1 2 1, this is 0 1 1, and this is 2 7 9. This is 0. So what we get here is that we get the first row as it is, that is 1 2 1, second row as it is 0 1 1, and the third row is that, so it will get multiplied and subtracted by zeros. Then here I'll get -2, so I'll get this as 3 here. So then here I'll get this as 9 minus 2, I'll get 7. Okay, so this is my new thing. Now I have to remove this 3. To remove this 3, what I need to do is that I have to put E3 2 with a value of E32 into P into A. So let me write straight away. So this is 1 0 0, this is 0 1 0, and this is 0. So I have to put this here -3 and 1 with, I'll write here 1 2 1, this is 0 1 1, and this is 0 3 7. So then I'll get this as the final terms, that is 1 2 1 0 1 1, and here I'll get this as 0 0. So then here it is 3, so 7 minus 3 is 4. So now it is an upper triangular form and my coefficients are 3, and so let me come back here. So my coefficients is 1 is 2, so that we have from this here, one is a -2 and the another is the multiplier, so the another multiplier is -3. So it means the 2 and 3 with 0 1 0 1 0 0. So this is my lower triangular form, and upper triangular form, what did I get is that finally 1 2 1 0 1 1 1 2 1 0 1 1 and 0. What did I finally get? 0 1 1 and 0 0 4. So this is my L into U. It's a factorized. So now it means the P into A can also be factorized into, it means P is nothing but the permutation. We have interchanged the rows, so P into A can be factorized as L into U. So if you want to just write a statement here, so then we can write like this. So write this here. If A is invertible, if A is invertible, then a permutation P will put its rows in the right order to factor P into A equals L into U. So there must be a full set of pivots after row exchanges for A to be invertible. Okay, so this is what, if you want to put back in a statements. So that's it. So in the next session we will talk about the vector space. Thank you.